Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. My name is Arun Lakshmanan, a senior open source specialist SA working at AWS. Today, we are going to explore the options to get the most out of your operational analytical workload deployed in Amazon Open Source Service. The agenda is to have a quick overview of the service, the features that can enhance your experience of operational analytics, best practices at the high level. The OpenSearch project is an open source suite of tools that includes OpenSearch, a general purpose search and analytical engine built on Apache Lucene, and OpenSearch dashboards, a visualization and management interface for OpenSearch, a set of plugins that provide additional features like anomaly detection, alerting, observability, and security analytics, and a set of client libraries that makes it easy to interact with OpenSearch from different programming languages. There are more than 55 partners in the open source community and multiple service providers along with AWS, including Oracle, Ivan, and Bonsai. OpenSearch service is a fully managed service that makes it easy to use OpenSearch in the AWS cloud. You don't have to worry about deploying, scaling, monitoring, or securing OpenSearch as the service takes care of all that for you. You can change the instance type, perform in place upgrades, and other configuration changes all without any downtime. You can get hourly incremental backups, multiple storage tiers, high availability with multi AC standby, and no data transfer cost if it gets deployed across availability zones. In short, Amazon OpenJet service makes it easy to use OpenSearch without having to worry about the underlying infrastructure. OpenSearch can turn a stream of log lines into meaningful insights. You can use OpenSearch to monitor your applications, troubleshoot problems, and gain insights into your user behaviors. You can use OpenSearch to answer questions like, is my infrastructure is rightly working, from can I find bottlenecks in my processing user request? Before we dive into these features that enables you to achieve these use cases, let's take a high level overview of how you interact with OpenSearch service. A typical log analytical workload works by extracting logs from your log sources, converting them into JSON documents, and sending them to OpenSearch cluster. OpenSearch provides an API and visual dashboards that allow your developers, analysts, and DevOps engineers to search and analyze the data. It is important to define a life cycle for time sensitive data like logs and application events. The data is most valuable when it is fresh, as it can be used to identify and troubleshoot problems quickly. However, as the data gets older, it becomes less valuable and queried infrequently. In some cases, you may want to store this data for longer period of time for compliance reasons. Amazon OpenSearch Service provides three storage tiers to manage your data. Hot tier, which is the default storage tier that is backed either by EBS volumes or internal storage in the data nodes. Ultra warm tier is the cost effective storage tier that is less frequently accessed. It is backed by Amazon S3, which is durable and highly available storage service. So you don't need replica. You have an interactive query experience with the data in warm tier. If the data is locally cached, you will get a similar performance of hot tier, but it can only support fewer concurrent queries. Cold tier is the most cost-effective storage for archival purpose. It is detached from compute and gives you on-demand query experience. With an API, it gets attached to warm instances in seconds, and you can detach after your analysis. Index state management or ISM helps you to manage the lifecycle of the indices and allows you to define policies that automate the migration of indices or deletions based on criteria such as minimum age, size, or count. When the data is sent to Amazon OpenSearch cluster, it is first indexed into the default hard tier. Then, based on age, size, or document count, or simply by a cron schedule, you can migrate it to Ultra Warm instance. After the infrequent access time or other conditions, you can migrate even cheaper, colder tier. After the retention period, you can delete the index. You can choose to use storage tiers to store data for longer period of time, but it is completely optional. You can also automate the deletion process from the hard tier. In addition to standard metric based alerts, OpenSearch supports machine learning based anomaly detection. This means you can create a detector to watch one or more metrics. The algorithm will learn what is normal value for those metrics. It internally uses random cut forest algorithm to find the anomalies. If the metric goes above or below the threshold, the algorithm will send out an alert. This can help reduce the number of false positives, and it does not require you to be a machine learning expert to use. OpenSearch has an observability plugin that provides insight into your distributed application system. A modern application architecture is typically composed of many different microservices. It may be time consuming task and might require some guesswork to identify the issues with a highly decoupled system like this. Observability is the ability to understand the state of the system by collecting and analyzing data from different sources. OpenSearch supports OpenTelemetry, which is a specification from Cloud Native Computing Foundation, CNCF. You can either instrument the code manually or automatically to collect logs, traces, and metrics and send it to OpenSearch. This data can be used to identify performance bottlenecks, detect errors, track user behaviors, or even troubleshoot the problems. These are the screenshots shows the feature of OpenSearch Observability plugin. These are pre-canned dashboards can help you to understand the state of your application. It provides a single pane view of trace groups, service maps, latency, error rate, and throughput data. The data is color coded based on metrics that makes it easy to identify the bottlenecks in your execution path. Security is everyone's responsibility. Early detection of potential threats is an essential for any organization. OpenSearch introduced security analytics earlier this year with OpenSearch version 2.5. With OpenSearch service, you can systematically detect potential threats and respond to the system state. To automate the security process, security analytics with OpenSearch, you can follow the workflow. Identify and ingest logs. Security analytics supports more than a dozen standard log formats, including VPC flow logs, network events, DNS logs, and Apache access logs. You can use OpenSearch ingestion service to ingest the data from your sources into OpenSearch cluster and then create detectors. Detectors are the core components that are configured to identify a range of cybersecurity threats. These use log data, evaluate events occurring in the system, and apply a set of security rules specified for the detector to determine findings from these events. Security analytics uses pre-packaged open source Sigma rules, which is like over 2,200 rules that are pre-packaged, describing the relevant log events. But with their inherently flexible format and easy portability, Sigma rules can provide users with options for importing and customizing these rules. You can take advantage of these options either using OpenSearch dashboard or through APIs. When defining a detector, you can specify certain conditions that triggers an alert. For example, you could specify that an alert should be triggered if a certain number of failed login attempts are detected within a period of time. These are some of the screenshots from the Security Analytics plugin where you can see the recent findings and alerts. There is a correlation engine and correlation graph, which are powerful tool that can help you to identify potential security threats. By understanding the relationship between findings and different systems in your infrastructure, you can be more confident that you are taking action to mitigate the threats. All these features are come standard with the Amazon OpenSearch service. Best practices begins with the sizing the cluster. The first step in the infrastructure planning is to estimate the amount of storage you need. You can use simple formula to estimate the on-disk size of your data, which is approximately 2.2 to 2.5 times the size of your data. This is because you need to account for replicas, index size inflation, and deployment overhead. Once you have estimated the amount of storage you need, you can start to estimate the amount of CPU you need. You should evaluate how many shards will receive the request. Each index is comprised a set of shards, and those shards are active based on how you are writing the data. In the event analytics space, today's index will have more active shards. Yesterday's index will have fewer active shards, and the older indices may have far fewer active shards or may not have any active shards. Ultimately, you want to put CPU against the shard to ensure that you have enough processor capacity to handle the workload. Our general best practice guideline is to use 1 and 1.5 CPU per active shard in the instance you deploy them. OpenSearch service supports variety of instance types. R6G and i3 are the best performers for high capacity and high volume production workloads. C family instances are often relevant for search workload, which tends to really need more processor than it does storage. A mini checklist for best practices. Deploy, monitor, and adjust. When deploying a cluster for log analytics, it is important to remember that it is not possible to predict the exact infrastructure requirements at the beginning. There is no deterministic formula that can tell you what you exactly need. The only way to correctly scale OpenSearch is to start with a predicted configuration, run it with the actual data and schema mappings, and measure the performance and monitor the utilization of the cluster. This will allow you to adjust the configuration as needed. You need to repeat this cycle as the usage changes organically. Each shard can potentially handle up to 50 GB of data. You can rotate the indices weekly, monthly, or even larger interval instead of daily. Always consider using bulk API to group them when you are ingesting to minimize the network calls and improve performance at the underlying Lucene level. Configure for high availability. HA domain is a new multi-AC with standby option which we introduced the end of last year that will make it easy to achieve 4 nines availability in a single domain within the region. Data nodes in one AC will act as a standby node in the event of failure, say node failures or a single zone failure. While the data gets replicated to those nodes, they will not serve any search traffic. The failover to standby within a minute when there are any infra issues. These standby nodes will then serve traffic, and the AC that has the issue will become standby once the issue has been resolved. It is important to maintain 25% of the free storage in your OpenSearch domain. This will give you headroom to observe volume spikes and a workspace for OpenSearch internal housekeeping routines. If the storage reaches 95%, the cluster will become read only, writes will get blocked. It is generally recommended to maintain the active shard to CPU ratio of 1 to 1.5. This means you need to have 1.5 CPU cores for every active shard in your OpenSearch cluster. It is important to monitor the size of your shards in OpenSearch. For append only indices such as logs and events, the shard size can be up to 50 gigs. For mutable data such as application data, the shard size can be up to 30 gigs. A good rule of thumb is to have 20 to 25 shards per GB per gigabyte of JVM heap. The OpenSearch process gets half of the available memory up to 30.5 GB, and the remaining memory will be used for a file system cache and other processes. This means the maximum number of shards you can have on a larger instances can be up to 600 to 750. It is important to note that these are general guidelines. The actual number of shards that you can have per node will depend on specific workload and the configurations that you have. You can use our open source monitoring tool that is available in the AWS samples repository in GitHub, which can be installed in your AWS account. The tool will find and collect metrics from all available clusters, including OpenSearch serverless collections and across regions. It provides a global pre-built dashboard that you can see the cluster health of all your clusters across regions, and it will also set up an alerts for essential signals. Thank you.